Yay. Morning. Are you ready for security talk? Because it's going to be tough. Are you ready? Sure, we can start. I don't hear you. Yes, security, encryption, all the things. Yeah, let's start. So, my name is Anastasiia, and I was mobile developer. I was doing a lot of applications many years ago, but then I switched to security completely, and now I'm working as a product engineer at Kozak Labs, small cryptographic software company. What we do there, we create tools for data protection, for encryption. So I maintain some open source cryptographic software, I do some trainings, I do some security engineering, all this stuff. At Kozak Labs, we have a team of cryptographers that are working on R&D, novel cryptographic technologies. Then we pack all the things into libraries and frameworks, and then on the tools that we license. So other companies usually take our tools to make data security in their product better. And that's why I know I've seen a lot how bad security is in typical applications. To put it simply, well, in crypto we trust, but in usable cryptography. So our idea is that, yes, cryptography is cool, but usability is more important. So what we do, we try to make all these shiny cryptographic tools as usable for end users as possible. And this is what we will talk today. First of all, just a little bits and pieces about security engineering, how to make decisions in security. Then I will explain you a real-world case about end-to-end encryption in Bear application. And at the end, we will have a cat, because the security talk, we need to have cats, right? Let me not actually spend a lot of time on that, why we need to encrypt the data. You know all these things, right? Say yes. Yes. Like lie to me, okay? So we do know that GDPR, Articles 32, 33, 34, 35, actually requires to have encryption of sensitive data. We do know that if you create applications good enough for Department of Defense, you need to encrypt data all the time, except the short time where the data is being computed. You know that Apple and Google are changing data policies, user policies, so they actually push you as a companies to make more data encryption. You know all these things, right? So we won't stop on that. What we will stop on is how to make security engineering decisions. Sometimes people say, okay, let me build this feature in my application just because I can. Which is a valid statement, but often people don't realize risks behind this statement. The second idea is, well, you know, every application should have some security features, so let's have in our app. Again, kinda nice rule, but if you're creating Instagram for kittens, probably you don't need a lot of encryption there. Depends, but still. So what I suggest to think about is about risks and threats. Before implementing some security control, try to think what data are you protecting, against what risks do you have, and what threats do you have. Next small bit is about boring crypto. Have you heard boring crypto term before? No? Yes? Can you raise your hands? Who heard? Okay, not so many people. Okay, so the idea is very simple. This is a concept by Daniel Bernstein that cryptography should be boring for users, for developers that use it. Cryptography should work, should be strong, should be usable, easy to integrate, and don't need to be updated. Of course, this is just an idea, this is just a concept. But when you're selecting an instrument, a tool, a library, keep in mind that good libraries are boring libraries. And just to realize how much effort you will need to put into integrating encryption in your application, how many mistakes you can have, think that ciphers are small bits that had a lot of parameters, and you need really to understand what's going on to use a cipher. In cryptographic libraries, we usually have a lot of ciphers, but still, first of all, you need to understand which cipher to use and which cipher to select, and then what parameters to put. Common Crypto and CryptoKit are crypto libraries. Then we are moving to crypto systems. Crypto systems they use a set of ciphers to close one security function. So the abstraction level is higher, and usually crypto systems are based for one problem, like to solve one problem. For example, TLS. This is a crypto system. And usually on crypto system level, you don't need to select ciphers because that's already done for you. And at the end, box solutions. Box solutions, typically, they are already made applications that you can use to cover some security problems you have, like SSH, for example. That's kind of box solution. You don't think even about ciphers inside. So the idea is, when you move on this scale, try to start from box solution if you find them, from crypto systems, boring libraries, and only then, if you understand what you're doing, if you have some cryptographic background, if you can distinguish IIS, CBC, and IIS GCM, select cryptographic library or cipher. This third small bit before we start is about defense in depth. Defense in depth is yet another idea in security engineering. Defense in depth says that one security control, one security measure is not enough. You need to have a set of independent but interconnected security measures that protect your sensitive data. And of course, when we talk about data protection, we build defense in depth starting with encryption. So we encrypt the data all the way, and encryption is our first and the best security control. But encryption itself, it's not enough. That's why we add other security measures to make sure that we will have multiple of them to protect the most risky places. And usually you can illustrate defense in depth like this, like lines of defense around your data. You have your data, make sure that it's been encrypted while stored, right? Data address encryption. Then you need to handle authentication access control to make sure that only needed people or like users or like applications can access this data. Then most likely you will need to transfer this data, so you need to handle the transport encryption. And only then we are talking about reactive controls like monitoring, logging, intrusion detection systems, like things like obfuscations, honeypots, yada, 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 yada. So lines of defense. And this looks really, really, really the same as this thing. Do you know what it is? What it is? Cable? Say it louder. Yeah, that's transatlantic cable. And the real data is these small orange, reddish fiber optic cable. It's really, really small. And all things you see, all these layers, this is defense in depth. These are layers of defense to be able to carry these small signal cables. And the last one layer, the gray one, is a layer that's a protection against sharks. So yeah, let's get to the real app, okay? The name is wrong. Actually, we spent much more much more, maybe even more. But the idea is that when you're building an encrypted system, you don't really spend time on encryption. If you use boring library, you don't need to handle that. But you spend time on key management, on user-facing features, right? Key management, you know what key management is. How to generate keys, where to store keys, how to revoke them, how to make sure that they are not leaked. And today I'm gonna explain how we build end-to-end encryption into Bear application. Have you used Bear app? Yes, so you know what it does. This is really cool, really nice note-taking app for iOS and macOS. And we create like end-to-end encryption of user nodes. So as a user, all your nodes are encrypted and being synced between your iOS application, your like iPhone, iPad, and your macOS Bear application, end-to-end synced for one user. We wrote a couple of blog posts about that, so my talk is really, really short, but if you want to catch all the details, read blog posts by Cossack Labs and by Bear, how we did it, to get the code, to have some links, to read some links. Okay. The problem here is that Bear application, it's not a financial app. We should not stress users to create really good passwords. We should not interrupt the user flow. That's why encryption is smaller than key management, because we build really complicated system not to interrupt user flow and to integrate seamlessly. At the end, what we encrypt each node of each user per each implication using unique encryption keys. We didn't store these keys. We didn't store user passphrase, user password in a keychain in plain text, but we got everything synced really fast, really smooth. So if you type your node on iOS and then open macOS, you see all the content synced. Yeah, as I mentioned, UX is important, and this was the problem, not the encryption. Let's see how node encryption is different from node locking and application locking. On the left, you can see node encryption and node locking. So you just need to open a node. It will ask you for your password or your Touch ID or your Face ID, and you see node content. On the right screen, you see application locking. So you can lock the app. It will ask your Touch ID, Face ID, or password when you open it. Super easy. But still, a lot of people don't understand that these are actually different things. How node encryption differs from node locking? Okay, you agree that these are different things? Yes. The fact is that encryption, well, that's encryption, and locking is actually, that's authentication. So node can be locked. It will require to perform authentication using Touch ID, Face ID, password, but not encrypted, but stored in a plain text. Node can be encrypted, but not locked. Right? And node can be both encrypted and locked, and this is what we have in Bear. But technically, these are different processes. Before we start implementing encryption, remember we told about risks and threats. So before building security code, we actually need to think what data we are going to protect and from what we are going to protect it. And this is the data model of a Bear app, really simple, really straightforward. We protect the node text, which is plain text. We have a user passphrase, and this is important. Passphrase is basically the user password, but I know that many developers confuse password and encryption key. So I use the word passphrase. This is something user created. This is something from user mind. So we have the user passphrase, and we have the node encryption key, which we use to encrypt the node. This is a date model, super easy. This is the threat model. What bad can happen if? For us, the worst scenario if we lose nodes. So if we encrypt nodes but won't be able to decrypt them. And if we leak passphrase. Because users, you tend to use the same passwords again and again and again in many applications. So if we leak the passphrase from Bear App, there is a chance that someone will use it and try to break, right? That's why this is our threat model, and that's why we don't store user passphrase anywhere in a plain text. It's not really critical to lose node encryption key because we have unique encryption keys per each node. So if one key is leaked, maximum, the worst scenario, that one node will be decrypted. But that's all. Now we build a trust model. Whom do we trust? Talking about Bear application, we have iOS system and macOS system and a transport between them. So we really trust that the data stored inside application in a keychain or in a device storage can be secured. We trust Apple. But we don't really trust the medium. We don't really trust the transport. Bear App, they uses iCloud, like magic technology, no one knows how it works. And we don't control it, so they don't have their own backend services. They use Apple backend services. No one can control it except Apple. That's why we don't really trust it. We don't know what's going on there. And we don't trust iCloud Keychain as well. Because there are really a lot of ways to break iCloud Keychain. Device keychain is kind of good, but again, when you have the transport, these make things less trusted. So, data model, threats model, trust model. This is the simple key model. What we have a node, easy. We store encrypted text in node, and we have some unique ID of this node, super easy, just UDID, nothing really magic. And we have a metadata of a password. So we don't store the passphrase anywhere, but we store some details about it, like password ID, hint, version. And each node knows what exact password was used to encrypt it. Now the tricky part. As I mentioned previously, we have user passwords, user passphrase, right? User password that we don't store anywhere. So this is something from user mind, and we don't need to store it. And then we have those unique node encryption keys for each node that we also don't store anywhere. We just calculate it, use it, and wipe from memory. So the question is, what do we need to store if we can't store passphrase and we don't want to store encryption key? We need to have something in the middle. And this thing in the middle is application encryption key. This is a temporary key. It's been derived from user passphrase, and we store it. It's unique per user, per application. We can cache it inside the app temporarily, and then we derive node encryption key for application password key. Unfortunately, we need to sync all these things between many Apple devices that users have. So that's why we actually we sync user passphrase in iCloud Keychain, but we do it encrypted. We don't put plain text there. And here you can see the levels of cache. Why we do this? Because we don't want to ruin user experience. We don't want to ask passphrase every time before encrypting the node or before decrypting the node. But we can store it because it's a critical bit. So you understand the train of thoughts, right? So we have the user passphrase, which is not stored in the app, which is stored in user mind, or what is better, in user password manager, like 1Password, KeePass, LastPass, or user keychain. Then we have this application encryption key that is stored only in a variable inside our app. It's actually mutable data. So we put a key here, we derive it, we put it in mutable data, and we zero it after locking the app. And we have node encryption key that again is stored in a variable. We generate it, we use it to encrypt a node, to decrypt a node, and wipe it from a memory. Encrypted passwords, as I mentioned previously, is stored in iCloud Keychain because we need to sync it between devices. And these are a really short slide with code how to derive keys from user passphrase. This is a pseudocode. It's almost like a Swift code, but not really. So what we need to derive application key, we need to have user passphrase, and we need to have some specific salt for the application. What we use to derive node encryption key, we need to have this application encryption key, unique node ID. Let me see if I have this. Well, unique node ID, and then we derive unique encryption key for each node. That's pretty much clear here, right? Lie to me. Node encryption looks even easier than key management, than key derivation. For node encryption, all we need to have is to have like node text, this unique ID of the node, and encryption key. To decrypt node, we need to have the same. Actually, under the hood, we use IS-256 GCM with random IV and with this unique context. So every node, even if the node content is the same, even if you want to encrypt hello, hello, the encryption keys are different and resulting encrypted data is different. So each user of Bayer application has different encrypted node using different encryption keys. What we did right now, we thought about risk management, trust management, threat management, and we implemented the smallest bit, the data encryption. But remember defense in depth, we need to implement other security controls. So this is what we have right now, just the smallest bit. This is what we need to make sure that our system is secure. We need to handle data stored in memory, right? We need to zero it. We need to think about user experience and typical mistakes user make. Then we need to move to the UX level, to the UI level probably. We need to think about auto-locking timer, so like user-facing features that will make our system more secure, but without ruining user experience, as I said previously. Fortunately, for Bayer application, we don't need to handle certificate pinning and TLS because Magic iCloud, because Apple handled this. But if this were our backend server, this small square with certificate pinning would be a large thing to do as well. At the end, to make a really protected app, you need to have all those techniques that are not the first step, like obfuscation, like protection from reverse engineering, from debugging, just to make sure that you have all these layers of defense. Right now, I just want really short to tell about these three. So hint encryption. We talked previously that users tend to use the same passphrase again and again and again, right? And applications suggest to create a hint in case users forget their passwords. And what users use as a hint? Password. So it doesn't make any sense to build all this encryption, key management, all this complicated flow if we store hint in plain text. That's why we need to encrypt hint. And this is the line of defense. Next thing, when you're working on system, especially security system, you can believe that it will be secure forever, but it won't. So from the day one, when you design your system, you need to keep in mind that you will improve it. That's why we have version everywhere. Because, some vulnerability can be found in a cipher or in a library, or we will need to change the cryptographic library, or we will need to to update the flow. That's why everywhere where we handle encryption, we have this version. And now Bear has encryption version 1, but they already have a mechanism, a technique to migrate to encryption version 2. So next time, during normal changes, the users can open the app and application will, migrate the data inside. Or if they have really a lot of users, if someone will find a bug in our implementation, we will increase the encryption version and we will release a patch, a hotfix, and we will make users to do this migration. Like on the next application launch, we will migrate the data scheme, the encryption scheme. Yet another line of defense. Next, auto-locking timer. So when you lock application or when you lock node, usually you lock it after 10 seconds of inactivity. 10 seconds, 30 seconds, 5 minutes. And the problem is that usually people calculate these seconds like this, having date and then having time interval since now. Compare and understand if it's already a time to lock or we still can wait. What's the problem here? Can you find a problem? Say it louder. Yeah. First of all, users can open settings on their phone and they can change the time. Second, time zones, all these weird dates like February 29th, like leap year, all these date changes in spring and autumn. There are so many things that can go wrong. So instead of using dates, it's better to use monotonic timer, which is just a counter. It's not a real timer, it's just a counter how many seconds or milliseconds, how many milliseconds from the last reboot. So this is a timer that is always increasing and goes to 0 after reboot and then increase again. And this is a Swift code that uses this timer. Of course, it's not very, nice, but still, it's monotonic timer deep inside iOS. And if you follow this Twitter thread, you can read that actually we found out a lot of applications that don't use timer but rely on date. And you can go to the settings, change settings, get back, and unlock an app. Okay, let's wrap up. Here is a kitty. What we done? We thought about application and data model of this app, risks and threats, and we use not really complicated, but kind of okayish encryption scheme to make sure that we encrypt the data and we don't store passwords in a plain text. But encryption is not enough. That's why we built defense in depth, a set of independent but interconnected security controls, like encrypted hint, encryption versioning, all these timers, all these lockers. And at the end, we can get this picture, lines of defense. And the problem is that end-to-end encryption in Bear application, this is very, very, very simple use case from cryptographic point of view. We have this end-to-end encryption only for one user. Yes, multiple devices, yes, synchronization, yes, fast and smooth, but still only one user. In cryptography, if you want to do more user-friendly things, like encrypt data, but being able to search in this data, or encrypt data end-to-end, but being able to collaborate on this data, the more control, the more user experience you want, the more complicated it is from cryptographic and security engineering point of view. So, when you design a system, remember that you're responsible for all these fails, that security will never be done, and that's up to you to make a system that will be reliable and strong and secure and will last for ages, well, at least for months before next iOS release, or Xcode release, or iPhone release, or macOS release. Okay, that's all. Thank you a lot for attention.
Thank you. So, my first very important question is, why always cats? Like,
why cats?
No
okay,
dogs,
okay,
never
okay.
dogs.
Who prefers cats over dogs? Who prefers dogs?
Ah, see?
Okay, next time, I promise, I will get puppies. Okay? Okay.
Perfect.
Like real ones.
No, pictures.
I really like the idea that, for example, Bear is an app that is really pretty and simple and really smooth to use, so you don't distract the user. But that comes with also a lot of design thinking and how you do that. And sometimes, you know, like management in companies are not really thinking about that, about security. So as a developer, should I try to convince my, my company to invest in security, or should I just wait for it to come from the management? Okay, so it depends. In some industries, you're kind of safe, because when you deal with financial data, medical data, when you're in a regulated industries like critical infrastructure, you already have all these regulations, so they push you. So if manager says, let's postpone encryption, you can say, come on, this article of this law, like of this regulation actually says that we need encryption. Right? But when you do some like smaller, more simpler applications, you can think about GDPR, for example, at the same case, but most likely your manager will understand money problems, like fines, right? So in security, it's called FUD, fear, uncertainty, and doubt. What you need to do, you need to search for cases, for data leaks of real-life examples of what happens. Real-life examples of applications similar to yours, or in the same industry, for example, or using the same technologies. And you can see, like, usually in those articles, you see amount of money they like spent, they lost, and you go with these articles to your manager. I think there is a website like collecting all the data leaks that you can find. But it's amazing. Like you type your password and you find out that have I been pwned? Yeah. So, but you know, in security, it's not really recommended. Like among security people, it's not really recommended to fear, like try to scare your managers, but it works. There's a question that I was wondering is, when you think about all those security like possible leaks, you never know if there is still a leak or not, if your app is secure enough. So do you have ways, how would you test, how would you try to find out where are the holes in the security of the app? So there are standards, you know, OWASP, OWASP, right, OWASP. These are organizations like non-profit, just community of people who does a lot to create all those standards. So for mobile application, take a look on OWASP, MASVS, Mobile Application Security Verification Standard. This is a huge checklist with questions. The problem with huge checklist is that sometimes it's hard to... Okay, it's not really huge, only 8 chapters, you see? It's not really huge. So what you do, you assess, you check your application in using this checklist. And again, depending on industry, they have light version of checklist, smaller, which is called level 1 for
non-critical applications. And they have larger version, which is called level 2 for critical apps. So you have like different amount of questions. And you use this checklist to understand, just to say yes or no. Do we have it? Do we support it or don't? And then you have the scores. And you're like, how bad you are.
Yeah.
And having the score, this is something you can measure. So next sprint or next quarter, you can concentrate just a little bit on these issues and make this assessment again, and you will see how your scores has changed.
And improve step by step.
Yeah. So for mobile, it's OWASP, MASFS, and you can find great book, MSTG, Mobile Security Testing Guide, which actually explains how to test all these things from checklist. For web, it is OWASP, SVS, without mobile.
Yeah.
And yeah.
Okay, we'll try to gather those links on the website so that you can find them out.
And I mean, can we do an auto assessment in a way, or
Yeah, you can do, but you can't cover everything with auto assessment. So what you can do, you can add codes like static code analyzers, dynamic code analyzers. You can add those tools like dependency management tools. Right, to check that if your Cartage dependencies or CacaoPod dependencies are vulnerable, then you can. Well, if you use these GitHub alerts, you know, when it says that you need to update this library, you need actually someone, some mechanism or some bot to keep an eye on these alerts, because just having alerts, it's not enough. You need to read them and fix them.
Yeah.
This is how it works. So yeah, you can automate part of these checks. And like for encryption, for security, I really recommend to have a lot of tests. Because first you need to have unit tests just to understand that your encryption is working for all these, you know, emojis, Cyrillic letters, Arabic alphabet, that you don't have problems with encoding. Right? And then you probably need to have integration tests between your application and like backend or application to make sure that transport is working fine, to make sure that data encrypted in one app can be actually decrypted in another one.
Yeah. A question that gets always asked, and how does one educate oneself about app security?
Follow my Twitter. No, well, not really. The problem is that there is no one book. It's not that simple, right? There is no one book. And again, as software development, security is constantly changing and improving. So you can follow, for example, OWASP organization. They try to update their guides once a year or twice a year. Then it may be nice to follow, again, Twitter accounts from people in an industry or from companies working in industry, and follow their, add your email to newsletters connected with security, because security is a huge, huge domain. And right now we were talking only about small bits, cryptography and security engineering.
Yeah.
And a lot of companies are actually asking about that and wondering how they respect GDPR or all other rules. And it seems that in the tech industry, we don't talk a lot about that. And yeah,
we have a blog post in our blog, really long, that explains technical aspects of GDPR and where you should use encryption, pseudonymization, anonymization, and how to do all these backups if users don't want their data to be stored. I will send you a link, sure.
Okay, but the good thing is also, once you know more about that and how to put that in practice, it's becoming a superpower also.
Another question from the audience. It's quite specific but interesting. How do you store the salt for deriving the password in a secure manner?
Store or generate the salt.
That's the second one.
Oh, generate the salt. So it might be a little bit unclear, but for all these key derivation and encryption, we use different salt, and we actually generate it on the first run, and we store it in the app. Salt is not secret. Salt is kind of, well, it's not super public, but it's okay if it will be leaked. So we generate this salt, and we use it during key derivation or encryption.
So it just remains on the device.
Yes.
Yeah.
And as soon as you need to sync all the things, it remains in iCloud Keychain as well.
Okay.
But again, this is not a secret bit. This is bit used to create, like to derive keys, for example. On some of my slides, I had a blog post. So the engineering blog post, it actually explains all these questions there.
And in part of your slides, you had the certificate pinning, and you said, okay, in this case, we shouldn't like handle this because Apple does that for us.
Yeah.
At what extent, like, we can trust those kind of pre-made services? Are that as secure as we should, as we need?
Well,
Should we need to be paranoid?
well, yes, yeah, there is a paranoid point of view where you don't trust all the third-party, all the SaaS services, like cloud services you use. But in the real world, of course, you want to save money and you don't want to have these services like inside your infrastructure. So again, it really depends on your industry and risks. So if you use third-party services, that's fine. But keep in mind that you don't control them, and you cannot actually be sure that data from the services is like your original data. So then, like, when you build the security design scheme, don't trust this party a lot, right? But it's fine to use it as an intermediate. It's fine to add data encrypted there, because again, having the same things inside the infrastructure, that's long and expensive way.
Yes, always a trade-off.
Yeah.
Okay.
All right. Thank you
very
very
much for this
Thank
talk.
you.